You know exactly.
Do we need to go over 38 through 41? Yes? Okay. All right, what about 38? Do y'all need to go over 38? Yes? Okay. Let me zoom it in a little bit. So 38 says what is the area? And it gives you all the vertices already. So let's see. How tall? Let's see. First of all, what is area? Base times height, right? Length times width, base times height, whatever you want to call it. Okay, so how far over did this go? 10. Oh, I was looking at the 6. And how tall did it go? 6 is the y. 0 was the y. From 0 to 6 is how much? 6. And what's 6 times 10? 60. Just G. Alright, do we need to go over number 39?
Yes.
Alrighty. For every pair of natural numbers n and m, to which of the following sets must n and m belong? So, what were natural numbers? Counting numbers, right? Okay. So, including 0. Hey, Sarah. So give me a number that you want n to equal. 4? Okay, give me a number you want m to equal. 8? I heard somebody say. Okay, so what is n plus m? What is 4 plus 8? That is 12. Oh, sorry. Okay, so if you get 12, is that a natural number? Is that from 0, 1, 2, 3, 4, 5, 6, 7, 8? Yep. Okay, so that's 1. So that's not going to be D. It's not going to be C. It's not going to be B. So it's either A or E. Alright. What about, is that a, what number, what does it say next? An integer? So is that an integer? What were integers?
Numbers.
What kind of numbers? Negative and positive numbers, right? So, is that an integer? Is that a positive number or a negative number? Yep. Okay. So let's see. Does that narrow it down? Nope. Those both have 1 and 2. Let's see. Yeah. Let's see if it's 5. Skip that. Is that a complex number? What was a complex number? Let's talk about real. Let's do real numbers. Is that a real number?
Yes.
Yes, it is. What's the only one of these that has a 4? E. Okay. Does that make it easier for everybody like that? Okay.
What is a complex number?
Complex numbers is the A plus BI. Yeah. And the 12 would be where the A would go. All right. What about 40? Do we need to go over 40? You may need 40.
Yeah.
Yes? Okay. A certain perfect square has exactly 4 digits. That is, it is an integer between 1,000 and 9,999. A positive square root of the perfect square must have how many digits? So, let's think about a perfect square between 1,000 and 9,099. So, what do you want to do first? Let's see if 1,000 is a perfect square. Is 1,000 a perfect square?
Yes.
Okay, did you check it, make sure?
It is not.
It's not. Okay, so instead of thinking numbers that are perfect squares, how can I find a perfect square without having to use the square root button? You can square numbers, right? So let's think about a number we can square. Think of a pretty big number. 50? Okay, does that have 4 digits? Yes, it does. So let's see, if we take the square root of 2,500, since we just found that, what's the square root of 2,500?
50.
Well, technically it's plus and minus, but the only one it wants is the positive one, right? Okay, how many digits does that have? It has 2. Do you see how much easier that makes it when you think of real numbers? Got it good? All right, what about 41? Do we need to go over 41? Yes? All right, let's see. I haven't even read 41 yet. Let's see. Certain hotel has 80 rooms based on many previous years' occupancy rates. The owner of the hotel shows a daily action race and their probabilities of occurring for the coming summer season. Based on the probability distributions in the table to the nearest whole number, what is the expected number of rooms that will be occupied on any day during the coming summer season? So, hold on a minute. Can we come back to this one tomorrow so I have time to look at that one?
Yeah.
Okay, because we're at the end of class when I have time to look at it. We gotta make sure we get all our stuff in today. Okay, y'all remind me and we'll go over it tomorrow. All right, I gave you new set of notes. If you do not have that new set of notes, please raise your hand. I gave you new sets of notes the other day.
This is a lot longer.
It is a little bit longer. Sarah, Avery, the only ones that need it?
I think this is number the hardest test. This is the hardest test.
It's not. To each his own. Personally, I think, not personally, but with my experience, it's been quadratics and chapter 6 that are the hardest tests for y'all. Yeah. Now, is this going to be as easy? No, because we're putting everything together that we just did. It's not hard, but it gets a little confusing when we put everything together. That's the only thing. Okay, so we've got to get through this first page. Y'all ready? All right, do you remember when we did exponents a while back and in geometry and in Algebra 1? When you multiplied the bases like we're doing right here, what did you do to the exponents? You added them. Wait a minute, we're dealing with logarithms. Why in the world do we want to know about exponents? Because what was a logarithm the same as? It's the way to rewrite the exponents, right? So I can break this up. When you have products, when you have multiplication, you can say log base x of A plus log base x of B. That's the only property you need to know. All right, the next one. Well, excuse me, that's the only thing you need to know for that property, should I say. All right, the next one is quotient. When we divided the bases, what did we do to the exponents before? You subtracted. Same thing here. Log base x of A minus log base x of B. Okay, this is the only one that's a little different. You ready? Your power, whatever your power is, goes in the front, so it's P, and then it is log base x of A. That is a huge one, guys, okay? As long as you know these properties, it's going to be easy to rewrite this stuff. So here we go. Let's start with number 1. Number 1 just says to write each expression as a single logarithm and evaluate if possible, okay? So it is not possible for us to evaluate these yet because I'm going to tell you that, I think tomorrow. When we get to that. Okay, here we go. So what is subtraction? It is the quotient property. Very good. So I can say log base. Oh, let's go back over this. Let's stop and go back over this. Do they have the same base?
No.
Yes. Is their base bigger than 1?
Yes.
Is their base positive?
Yes.
Do you remember those 3 questions that we did every single time we did these problems? Keep that in mind when you get your test back in a few minutes. So we have log base 3. And this is the quotient rule, so 20 over 4. Can 20 over 4 be reduced? Yes, to what? 5 over 1 or just 5. Guys, please make sure you realize that 5 is not an exponent. It is a regular number. Most of you got so many points taken off of your homeworks and your tests because you wrote this 5 like this. Y'all are writing it like this for some reason. That's not where it goes. And if you wrote it like that, you got it wrong, okay? So if you wrote it like that, you better fix it right now. All right, what about this one? So you got a number in front. If you've got a number in front, that's the same as an exponent, right? So log base 2 of x squared plus log base 2 of y. Do they have the same base?
Why is it x squared?
Oh, it is a 3, isn't it? I must have been looking at the number 2. Y'all all right? Excuse me. Y'all understand why I put the 3 there, though?
Yeah.
Okay, cool. I was looking at the number 2 instead of the 3. All right, so do they have the same base? Is that base positive? Is it bigger than 1? Yep, so addition means to do what? Huh? Multiply, so it's x cubed, y. Very good. Not bad, right? Y'all okay? All right, last one. Here we go. So there's a couple of things together. So the 4 in the front means that it is a, bless you, it is a what? It's an exponent. So we have 2 to the 4th plus log base 4 of 4 minus log base 4 of 16. I just wrote that down. That's all I did. Just brought it down. And this is the only thing I did. Excuse me. Thank you. Okay, do you remember PEMDAS order of operations? When you had addition and subtraction together, what order did you do it in? The way that it's written. How do you read a book? Left to right. When you have addition and subtraction together, you do these 2 first, the way they're written. So we're going to do those 2 first, okay? So that, pretend like that's not there. That is addition. Addition means to do what? Multiply. So you have 2 to the 4th times 4. Do you have your handy dandy calculators? 2 to the 4th times 4, because addition means multiply. Yes, it's log base 4. All right, so what is 2 to the 4th times 4? 64. So it is log base 4 of 64. And then we're just going to bring down the minus log base 4, 16. Y'all okay? All right, now we have subtraction. What does subtraction mean to do? Divide, bless you. So this is log base 4 of 64 divided by 16. Does that divide evenly? How much does it give you? Positive 4. You okay? 64 divided by 16 is 4.
Is there a way to like the 4 log base 4 2 and the log base 4 16? Those are equal. Or they are like one of them is negative because the 4 is the exponent,
Yeah?
and then so it would be 2 to the 4th power, right?
Yeah.
And that's log 4 16, and then there's a negative log 4 16. So which one?
You could. You could. But I did want to make sure that you knew how to do this way, which is why I didn't show you that. But yes, you are exactly right. You could cancel those out. Very good. All right, here we go. Look at this question right here. Can you write 3 log base 2, 9 minus log base 6, 9 as a single logarithm? Can you combine those together? And that's the one on your test that you did so miserably horrible on because you did not ask yourself those 3 questions. Are they the same base? And your answer is no. So if I cannot write them as one logarithm, if I could not do that, what would it be called? No solution. So this answer is just no because it asks you, can you do it? So your answer is no. All right, number 4, we're going to go backwards, okay? So make sure you keep this piece up here handy, these 3 up here handy, okay? All right, we are dividing. Think about exponents. When you divide the bases, what do you do to the exponents? So same thing here. Log base 4 of x, subtract log base 4 of y, and you are done. Got it good? All right, now number 5, I have a quick question for you. You ready? Where is that exponent of which one? The 4 is the exponent.
So it's to the R.
Which one is it to, Scotty?
The R.
Why is it only to the R?
Because it's not.
Because it's not in parentheses. That R is the only one that has the 4th power, not the 3. So when I split this up, this is multiplication. So when you multiply the bases, you add the exponents. So this is log base 5 of 3 plus When you have an exponent, where does that exponent go? In the front, but it only goes for the r. Does that make sense to everybody? I'm taking it this is not as easy as the other stuff to y'all.
Yeah.
Seriously?
It's still easy.
Just gotta use your noggin a little bit. It's just not as like quick and quick and quick. Yeah. That stuff's gonna come into play, don't worry. Alright, here you go, number 6. Where is the exponent this time? To both of them, right? So when you divide the bases, what do? You subtract. So that exponent of 2 is going to go in the front. So it's log base 2 of y. Subtract. That 2 is going to go in the front again. Log base 2 of 3. I don't know why I just circled back. Sorry. Oh well. Here, we'll just circle all of them for good measure. Are y'all okay? Okay. What are we doing to a cubed and b to the 4th? What operation? Your multiplication. And when you multiply, how do you break them apart? You add. Very good. All right. So the a has an exponent of what? 3. So it'd be 3 log base 7 of a. What's the b have? 4 log base 7 of b. Are y'all okay? Not too bad, right? I can tell when it's harder for y'all because y'all are quiet. You don't say anything. Okay, we got 4 more. You ready? What's different about number 8, 9, 10, and 11? There's an equal sign, right? Which means we can actually solve and get an answer. You ready? Okay, so let's bring this together. Let's pretend like the 2's not there. Same thing we were doing. If I'm adding, how can I put them together? Multiplication. There you go. So log base 6 of x times x minus 9 equals 2. Are y'all okay with that? You can distribute that. Yep. That would be x squared minus 9x. And there's a reason why I put those parentheses, guys. Because if you don't put the parentheses, you're telling me that the log base 6 is only to the x squared and not to both of them, okay? So make sure you put parentheses. Now that's what we just took a test on. This is the last 4 problems on your test. How can I rewrite this?
Go.
So,
6 to the what power?
No, 6 to the 6 squared.
6 squared equals x squared minus 9x. Now what can I do, Matthew? Huh?
Where did you get the 6 from? Where did you get the 6?
Base exponents, what we just took a test on. This right here is what we just took a test on.
Okay, so then
Subtract it.
Well, I don't want to track the x squared. I want to keep him positive.
you subtract 6.
Well, what is 6 squared? 36. So you have 0 equals x squared minus 9x minus 36. Instead of writing 6 squared, I just put 36. Now what can you do? You can break it up. What are the factors of 36 that add or subtract to be negative 9? 3 and 12. Very good. What kind of signs for which ones? Negative 12 plus 3. Very good. So what are my 2 x values? Very good. For these, we can't because these 2 are not actually equal. You have this extra 2. We're going to learn how to put these in our calculator before much longer. I think it's tomorrow that we'll learn how to do that, or the day after that.
Are we going to end up graphing these?
Huh?
Are we going to end up graphing these?
Not right now, no. All right, number 9. You ready? Okay. So, what do you see first?
Miss Blackman?
Yes, ma'am.
Hey, did Sarah Bonnie's make it in?
Yes, ma'am. I sent you an email.
Okay, alright, thank you.
Uh-huh.
They're all the same.
Do what now? All the bases are the same. Okay, what else do you see?
There's
There's an equal sign. Do you see anything I can do, though?
You can, the right two terms, you can put them together.
Okay, well, hold on. D, go first.
Because the bases are the same, you can add the right terms in 27.
No.
Add the multiplier.
You would, remember the addition means to multiply. There you go. So log base 7 was 27 times 3. 81. Very good. And you might want to put like 27 times 3 or something right here so you can see where I got the 81. What about the other side? Scotty, were you saying something about the other side?
Huh?
Were you saying something about the other side?
No, I just said the right terms can go together.
Okay. Sydney, what were you saying? The 2 is the exponent. Very good. So I can write this as log base 7 of x squared. Now, because there's only 1 on each side, are the bases the same? Are they both positive? Are they both bigger than 1? This is the exact same thing we just took a test on now. What can I do? X squared equals 81. It's the exact same thing. We've got to put everything together, okay? That's the only thing that's hard about this stuff is putting everything together, knowing when to use what. So now you can square root both sides. And what's the 81? Square root of 81, and don't tell me 9. Plus and minus. Oh, look at them pencils going. It's going to stick one day. It's going to stick one day. One of these days. All right, 2 more. You ready? All right, what about 10? Do you see anything I can do on 10?
You can add the plus 2 together.
You multiply. When you add, you multiply. But do they have the same base first? Yes, that's the only reason you can do it. You okay, Matthew? You with us? Doesn't look like it. Now what can you do? Now you can distribute, okay? Keep those parentheses around it. We just took a test on this now. Very good. Base of 6, exponent of 2 equals x squared plus 5x. Alright, now what? X squared plus 5x. Where in the world did you get the minus 36 from? 6 squared is 36. But how'd you get minus? You must subtract it to the other side. Very good. Alright, what are the factors of 36 that add or subtract to be 5? 9 and 4, Matthew. Very good. What kind of signs do we get, though?
Positive 9, negative 4.
Very good. And so what are my 2 x values? Very good. Y'all okay? See, it's not too bad, right?
It's getting easier.
It's getting easier? Okay, well, that's good to know. All right, number 11, last one. You ready? And then we'll hand out your tests and give you some homework and stuff, and we'll go over your test from Monday. All right, what do you see first? Anything? The 2 can be written as what? The exponent. Very good. And then I'm just going to bring everything else down. I'm not doing anything else. Just bringing it down. What? Okay. Very good. When you subtract, you divide. So it'll be x squared over 5. And I'm just going to bring the other side down. Oh, Lordy have mercy. Oh, wait a minute. That's not so bad. We just took a test on this, right? Yeah? Do they have the same base? Bigger than 1? Positive? What's that mean I can do?
Cancel out.
Set the pieces equal to each other. Very good. How in the world would I go about solving that for x? There you go. Very, very good. What's 125 times 5? 625 sounds about right. And that's a perfect square, too. No, x does not equal 25. Uh-huh. Y'all okay? All right. So, if you flip over on the next page, you see that there's some stuff down there at the bottom. There's 10 whole problems at the bottom, right? 10 whole problems at the bottom. So, what do you think those 10 whole problems? That's your homework. Ding, 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 ding. We have a winner. Right down here at the bottom. You see it? It is due tomorrow, yes ma'am.
And it's optional review.
It's your grade. It's your option.
That is an option.
That is an option for you.
Optional review.
All right, y'all okay?
Yes.
All right, here's what we're going to do. From now on, we are going to do your tests, go over them. Who is that? So, who's that? Hey. Sir? So that should be what you got right there. Look at what problem?
Number 4.